So let's talk about atherosclerosis. And you can probably, if you read the content in the book in the chapter, or if you look at a different video and you understand it, you don't need to watch this video again. But if you don't understand it, then we'll go over it. So atherosclerosis, think of this as like a chronic inflammatory condition of the blood vessels, but it does a lot of damage and it's one of the leading causes of death in the United States. So this chronic inflammatory process, how does it start? Well, it starts with an injury to the tunica intima of the blood vessels. So remember, that's the inner lining of the blood vessels. And why is it injured? Well, there's a lot of factors that go into this, but this is one reason why high blood pressure, especially for prolonged or sustained periods, is so damaging, because it causes turbulent flow. It causes a whole lot of damage on the walls of the blood vessel. And all you need is a little tear. And then you have this inflammatory process that starts. And so this starts with an endothelial injury. So endothelial is the same thing as like the inner lining of the blood vessels. And then during this inflammatory process, you also have circulating lipids or fats. So this is like your cholesterol, your triglycerides. So these like fatty products that come and also deposit right under the lining of the blood vessel. And so conditions that are going to increase this process are like if you have high blood pressure or high cholesterol, high triglycerides. And so you have to have this injury, you have to have this like lipids, and everyone has some degree of atherosclerosis. But then, it's chronic and we develop it at different rates. And so after the endothelium is damaged, lipids leak out, but they really actually kind of attach to the internal wall of the blood vessel, and then macrophages eat them, right? Because this is an inflammatory process and they're part of that. And so you get these like fatty streaks. And so on the slide, it's a little bit difficult to see, but you can see these like little, like yellow streaks where the arrows are pointing. So those are fatty streaks. Everyone's got them. And then on the right in the same photo, you can see really significant atherosclerosis. So this is a lot of damage. And you can just imagine, like, if this is the inner lining, how turbulent that blood flow would be, right? And so as you get atherosclerosis and then you get even more turbulent blood flow, it's going to cause even more damage, right? And so this is kind of this like, circular propagating condition. And then you get scarring, and then you get these plaques, and then like they enlarge. And so the image that's on the right-hand corner shows just like a normal healthy artery. Probably no one, your age has like completely healthy arteries, because even children have little fatty streaks. And then here's a plaque, and you can see how that narrows the radius of the blood vessel. And so, thinking back to your blood pressure algebraic equation, what is that going to do if you just narrowed the radius of your blood pressure or your blood vessel? It's going to increase the resistance, which increases the blood pressure, which also causes more damage. So now you can see how like this just gets worse and worse, because, every time it gets damaged, it's going to basically, the damage that can be done basically enlarges the plaque, which narrows the radius of the blood vessel, which increases the resistance, which increases the blood pressure. And then because it's increased, it also has this like turbulent flow. And so that's, when eventually you get the picture on the right. And so what are some of the complications of this? Well, anything that you can think of in terms of like ischemia. So because it narrows the blood flow, then you can have tissues that aren't perfused as well, right? So claudication is when you get this like crampy feeling in your calves whenever you walk. And that can be because the metabolic demand is more than what your body can provide, because like it just can't keep up with that because the lumen of your blood vessels are so narrow. You can get angina, and that's when like the people feel their chest hurt and then take a pill or whatever. And so usually that is associated with activity, and it's the same thing. Like you have an increase in metabolic need, but you can't meet that. You can actually have more severe things because these atherosclerotic plaques can be damaged. It basically knocks the top off and starts another inflammatory cascade and has a clot on top of that, and that can even break off and go somewhere else. That's an emboli or embolus. And so that can cause a stroke, that can cause an infarction. In the picture at the bottom is basically the tissue in the foot didn't get perfused, and so it necrosed. You can have a heart attack, you can have a pulmonary embolus. You can also, like, because there's so much damage in that wall, and remember when we were talking about the biological mechanisms of disease, that your body can respond in a couple of ways. It can heal and restore like the tissue like it was before, or it can form a scar. And a lot of this is just scar. And so it's not as strong, it's not as, elastic as normal tissue. And so, you can kind of wear it down and it can balloon out. And that's what this aneurysm is. It's this aortic aneurysm. Remember, your aorta is pretty high pressure system, and this aneurysm is pretty thin. And so it's going to also create a bunch of turbulent flow in there. So there's not going to be forward flow. You have this potential of rupture, but none of these things are really good, actually. And so what are the risk factors? Well, think of the pathophysiology of atherosclerosis. It starts with an injury. So anything that increases the blood pressure is going to be a risk factor, right? You need circulating lipids. So anything that increases the lipids that are circulating, whether you have like high cholesterol or high triglycerides, or during stress, during your sympathetic nervous system activation, one of the adaptations that's part of this whole fight or flight thing is to mobilize energy stores. And that's an adaptation so you can escape, so you can survive. But even with psychological stress, the same mechanism gets turned on and you're mobilizing energy stores. And so now you have more fats available that are circulating in your blood. And that's a bigger risk factor. Smoking increases basically reactive oxygen species. So that's going to do a lot of damage. It increases inflammation with cytokines. Diabetes is going to increase the circulating nutrients. Sometimes it's lipids, but even if there is an excess in glucose in the bloodstream, that shifts your body towards a pro-inflammatory state. So stress impacts all of these. All right, so next case, Max is stressed out. How might chronic and or frequent activation of the fight or flight response accelerate the formation of atherosclerosis? So I just told you, take a couple of minutes and see if you can repeat everything that we just went through.